Hello students, Straight here again. Today we have 12.4 notes on universal forces. Start off with some world very different from Earth, but still maintains many of the same forces. And we appear to have four universal forces that are completely throughout the universe, all through planets, stars, galaxies. And these four universal forces are electromagnetic, strong nuclear, weak nuclear, and gravitational. Universal forces act over a distance between particles of matter. Particles do not need to be in contact, and force is affected by distance. Now we'll look at each of these forces a little more in detail. Electromagnetic forces, magnetic forces are only forces that can both attract and repel. So, electric and magnetic force, two different aspects of the electromagnetic force. And this is always going to be associated with charged particles. Electric forces act between charged objects or particles. And nice thing you've seen before, objects with opposite charges attract and like charges repel. A little illustration of static electricity. In the dryer, clothes may acquire an electric charge and they tend to cling together. Magnetic forces act on certain metals, poles of magnets, and moving charges. Magnets, two poles, north and south, sometimes also illustrated as positive and negative. Opposite poles attract, like poles repel. Illustration, magnetic attraction holding the toy train cars together. The nuclear forces, as the name indicates, are in the nucleus. Two forces, strong nuclear force and the weak nuclear force, act within the nucleus to hold it together. Strong nuclear force overcomes the electric force of repulsion that acts among the protons in the nucleus. Protons, being positively charged, are trying to repel. They don't, and it's a strong nuclear force that's holding them together. And the weak nuclear force is involved in certain types of radioactive processes. Strong nuclear force, powerful force of attraction that acts only on the neutrons and protons in the nucleus. Very strong force, but it acts only over very short distances, about the diameter of a proton, 10 to the negative 15th meters. It's about 100 times stronger than the electric force of repulsion at these distances. So holds the nucleus together. Weak nuclear force, attractive force of short range, even shorter range than the strong nuclear force. It's only about 10 to the negative 18th meters, or about 1,000 times less than the strong nuclear force. And you have gravitational forces, the most common of these that people know about of these forces. Newton's law of universal gravitation states that every object in the universe attracts every other object. The gravitational force, attractive force between any two masses. And it depends upon mass and distance. Gravitational force proportional to their masses, meaning as the mass gets bigger, the force gets bigger. And it decreases between the square of the distance in their objects. As farther away you get, the less it becomes. And because it's squared, this makes a lot of difference. It is the weakest of the universal force, but the only one that will act over long distances. Moon's inertia is trying to make it move in a straight line and cause it to be moving away from the Earth. But Earth's gravitational attraction keeps the Moon in a nearly circular orbit. This is an example of what we call a centripetal force. It causes an object to move in a circle. So gravity, so the Moon's inertia and the gravitational pull of the Earth make that nearly circular orbit. So inertia is trying to make the Moon go straight ahead, or whatever direction it happens to be moving. Gravity is pulling it towards the Earth, and the result is this nice curved path. You combine the inertia with the gravity. The gravitational pull from the Moon produces two bulges in the ocean, one closest to the Moon and one on the other side farthest away from the Moon. So as Earth rotates, there are two high tides and two low tides per day on the Earth. So the rotation and the gravitational pull generates these tides. Artificial satellites, using inertia and gravity to maintain an orbit. If it's in a very lower orbit, it's slowed by friction with the atmosphere, and eventually will re-enter the Earth's atmosphere. To keep this happening, have to have a little energy input into it at times. Artificial satellites, used for many reasons. Earth's weather. They can maps of Earth's surface, telescopes, studying the climate, and radio and microwave signals. So lots of things we use satellites for. So they can receive and transmit waves over a long distance. A review question: only forces that can both attract and repel, as we stated earlier, are the electromagnetic forces. Nucleus of an atom is held together primarily by, and that would be the strong nuclear force and the weak nuclear force. Gravitational forces is faults, and that would be C. They become stronger as the distance between the two objects increase. They are the weakest of the forces. They act between any two objects, and they become weaker as the mass of either of the two objects decreases. So smaller mass, less gravity. And a center-directed force that continuously changes the direction of an object in motion, making it move in a circle, is also called the radial force. Not the radial force, faults, but the centripetal force. Oh, that's section 12.4. Sure you read the section in the book and add any additional notes you wish. And that's all for now. Till next time, straight.